Okay, let's solve the following problem. The amount of illumination of a surface is proportional to the intensity of the light source, inversely proportional. Let me write down in that as I read. So illumination, I will put mark down as an I, is inversely proportional to the square of distance from the light source. Okay, which is means it's a coefficient of proportionality, and it's inversely proportional to the distance, which is going to be d squared, from the light to the corner, right? So distance from the light source, and proportional, meaning directly proportional to sine theta, where theta is an angle at which the light strikes the surface. So directly proportional, which is going to be sine theta. Okay, this is algebra. You should know this, but whoever doesn't, I went step by step explanation. All right, so a rectangular room measures 10 feet by 24 feet. Okay, so 10 feet is 5 feet, it shows till the center, halfway. And so this is gonna be 10 feet from here to here, 10 feet. And length, it's gonna be 24 feet. 20 feet that you see on the picture, it's a half of the length, so 24 feet with 10 feet ceiling. Here it is, 10 feet, and this is our x, the height. All right, determine the height at which the light should be placed to allow the corners of the floor to receive as much light as possible. This is very practical question. So when you buy the lamp, you want to figure out how high to hang. So this is gonna help you to hang is as low, or figure out the height, so where you will get maximum light in the room. Okay, I kind of liked it when I read it, so I decided to bring it to your attention. Okay, since we have triangle, this light, the projectile of this light is creating a triangle with the right angle. Therefore, I'm going to use Pythagorean theorem, where distance d is our hypotenuse. So hypotenuse is equal square root of sum of squared legs. So one leg is our x, which is height. The other leg, it's 13 squared. Okay, which is gonna be x squared plus 169, right? Okay, now sine theta, let's find out. Actually, our goal is, since we need to find x, the height, right? So this formula, I is equal k sine theta over d squared, I'm going to express through x, right? So I can solve it for x. And that's what I'm doing exactly. Okay, sine theta is the height, the opposite leg, which is x, divided by hypotenuse, which is d. Okay, so from here I can write down x, and d also I'm expressing through x, which is going to be x squared plus 169. All right. So I have it. I express sine theta through x. I express d through x. Now let's plug in the formula and simplify. Okay? So I is equal k times x over its sine theta. I'm expressing sine theta, x over x squared plus 169 square root, and divided by d squared, which is going to be 1 over x squared plus 169 to power 2. Yes? Let's do some simplification. I is equal k times x over x squared plus 169 to power 1/2 and times 1 over x squared plus 169, right? Because square root to power 2, it's gonna get whatever underneath is out. Okay, so what do we get here? I is equal k times x over x squared plus 169 to power 3 over 2, right? Here we have degree 1/2, right? And here we will have degree 1. So 1/2 plus 1, 3 over 2 degrees. Okay? All right. So next, to find out the critical point, which is maximum or minimum height, we are going to take derivative, right? All right. So taking derivative for quotient rule, it's gonna be, if I have u over v prime, it's gonna be equal u prime v minus v prime u divided by v squared. Okay, u is gonna be x, v is gonna be x squared plus 169 to power 3 over 2. All right. So from here, we have di, we are going to take derivative by dx, right? di by dx is equal d by dx k times x over x squared plus 169 to power 3 over 2, and that is equal 0. Okay? All right. So from here, we have k, it's going to be x prime times x squared plus 169 to power 3 over 2 minus x squared plus 169 to power 3 over 2 prime, because we are taking now derivative of v, right? And times u, which is x in our case, and we divide by v squared. And divide by v squared, which is x squared plus 169 to power 3 over 2 squared. This is equal 0. All right? Next, simplification. So since we have k is a constant, it's not gonna play any role, especially it's multiplied, and that is equal 0. So it's not gonna play anything. Therefore, x prime is gonna be 1, right? So we're gonna have left only x squared plus 169 to power 3 over 2, right? And minus x. Now let's take derivative of this parenthesis. It's gonna be chain rule. 3 over 2 x squared plus 169 to power 1 over 2, right? Minus 1 we did. And then we are getting inside, taking derivative of x squared plus 169. Derivative of x squared is 2x. Derivative of 169 is 0. Okay, so I'm canceling this 2 in denominator and 2 is here. And what is next gonna be? Continuing simplification of this derivative. So it's going to be, let me see, x squared plus 169 to power 3 over 2 minus 3x squared plus 169 to power 1/2 is equal 0. So I'm taking as a common factor x squared plus 169 to power 1/2, and here I will have left x squared plus 169 minus 3x squared is equal 0. Okay, so we got product here equals 0. So x squared plus 169 to power 2 1/2 equals 0, or x squared plus 169 is equal 3x squared. Now this one on the right side, x squared plus 169 is equal 0, right? Because if I square it, right, I'm getting x squared plus 169 equals 0. And I'm getting x squared equal 169, which has no solution, this one, falling out of game. And let's solve the equation on the left side. We are getting here x squared. Actually, I shouldn't move to the right because I can combine here. Minus 3x squared equals 0. And I will get 169 minus 2x squared, right, after I combine these two, equals 0. Okay, and 169 is equal to x squared. X squared is equal 169 over 2, and x is equal 13 here, square root of 2. And approximately it's going to be 9.192 feet. And this is going to be our answer, which means the height of the light to be placed to cover maximum light in the room, so to cover all the corners, is 9.192 feet. Okie dokie, see you in next video.